Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, we're going to go ahead and continue on with the Metronome series. And in this one, we are going to actually load a sound that we're eventually going to play in time with our metronome to let the user know when the actual clicks on the metronome are actually happening. So before we get started, just wanted to make a few quick announcements. Big thank you to the new supporters on Patreon. I really appreciate that. And also, big thank you to everybody that has been listening to the Audio Programmer podcast. So we had a really nice podcast last week with Rob Banton, who is a senior audio developer at Ubisoft. Ubisoft is one of the biggest game studios in the world. And he had a lot of great insights to share with us. We had a great discussion about game audio and how it differs from just conventional audio. So be sure to check that out. We're on Spotify and Apple Podcasts as well. Just search for the Audio Programmer. So we're going to go ahead and get started. And what we're going to do in this tutorial is work on loading an actual file that we're going to be able to play. So I downloaded this cowbell from one of the free sample sites on the web. I think it was like SoundSnap or something. And we're going to go ahead and load that. And then in the next tutorial after this, we're going to go ahead and get it to play in time with our metronome. So we need a few classes to actually get this going. So I've just pulled up the Juce API here. And so one of the first ones that we're going to need is this one audio format manager. So we're going to need this class. So we can see that it's a class that keeps a list of available audio formats. Okay, so we're going to go ahead and put that in here. We just need to give it private access. It doesn't need to be public. So we got audio format manager and format manager. And I don't think that needs any sort of initial arguments or anything. So and then we can use this function called register basic formats. And this adds WAV and AIFF to the list of formats that our app can play. So in order to do this, what we could do is actually set up a constructor where we can just initialize all this stuff. So I'm going to set up a constructor here. And then here we can just do this. And then this is where we can register our basic formats. I always get nervous when it doesn't autocomplete. So some of you that may be asking, well, why not put that in prepare to play? Well, the reason is because every time we stop, it's going to call prepare to play again, and we don't need to register the formats every single time that we prepare to play our metronome. So that's the reason why we're doing this in the constructor, because this just happens once the object is created in our main component. Okay, so what else do we need to actually load this file? Well, we're going to need some type of file, the actual Juce file class. Oops, that's not what I want to do. So let's go to the file class. So we can go file. And there's like 35 classes that have file in them. We just need this one. So we got file here, and this is on my desktop. So I'm just going to use that as the location. I'll show you how to do that real quick here. So we'll just call it file. I'll just call it my file. And then what I could do is I could use this just to give our default location to the desktop. You can see that we have these special location types here. So it says a set of types of location that can be passed to this get special location method. So if we go here, actually let me go up to the top where it shows the return type, get special. Okay, so we can see that there's this there's this function called get special location that actually returns a file return type here. So what I could do is I could do my file, so file my file, and then what I could do is to pass in an initial argument, I could say file get special location, and then what I could do is, okay, so what location do I want? I want the desktop, right? So we could use user desktop directory. So we need file, special location type, user desktop directory. Okay, looks a little bit wordy, but it's not too bad. Okay, so now we have this, and then now what we need to do is we need to actually be able to search for the file on the desktop. So we could say auto my sample equals my file, and then we could use, I think it's find child files. Yeah, so we have this, and so we have this find child files, and then this one kind of threw me for a second. It says int what to look for, and then it says a value from the type of file to find enum. Okay, so that's what we need to do. So first thing we need to do is find child files, and then let's go back here, and it says a value of the types to file to find enum. So types of file defined. So we want to, so here it says if we want to find a directory, find a file, find files in directory, so on and so forth. So we just want to find files. So we could go file, types of files defined, find files. Okay, because we're searching for files. Okay, is that what I want? I don't think that, I think I messed this up. There are two different function calls that are available for this. So I'm just going to delete this. So here's one I want. So you see that there are two different function call options that I have here. I want this first one actually. So that's it. And then do we want it to search recursively? Sure. And there's actually a third argument here that find child files. And this is like an optional third argument, and we can put a string here of what exact file that we want to put in there, or what type of so we were looking for all .wav files, we could put just .wav in there, or if we were searching for anything, we could just put this little star. But in this case, I know what file that I'm looking for, and that is called cowbell.wav. Okay, and then this is going to return an array of files. Okay, so it would be an array of, if we have multiple files, say called cowbell.wav, they would, all those files would show up here in this array. So so we could just say auto my samples, and then we're looking for that particular type. Now what I'm going to do is I'm going to put an assert here, and I'm just going to say my samples, and remember that this is an array, so there should be, once this function executes, then if everything goes well, then it should find at least one file that's called cowbell.wav. So what I could do is I could just say my sample.exists. Okay, and what will happen is that if that file doesn't exist, then it will bring me to this line of code where my program will stop executing, and it'll say, hey, you don't actually have a file on your desktop called cowbell.wave. Okay, so there are a couple different ways that we can handle that. We could, instead of doing that, we could say if my samples 0 dot exists, then we could do like load the file, else, warning, some sort of warning window or something like that. Okay, but I'm just going to do it real quick like that. Okay, so now we've got the sample, and now we need to put it somewhere, right? So we've got this. So if this executes, it finds the sample called cowbell.wave. Now we need to put it somewhere. We need to put it somewhere in memory. So now we've got another class that we've got. So let's go back here. I think it's called like audio source or something like that. Audio format reader source. Okay, so an audio source that'll read from an audio format reader. So what I can do is I'm going to make this a pointer, and I'll explain why it should be a pointer in a minute. So this is going to be audio format reader source. And then I'm going to call this P because that's a pointer, metronome sample. Always a good idea to initialize this to a null pointer so it doesn't point anywhere just yet. And so what this will do, this will point us towards the sample that we want to play. So why are we using a pointer here? And this is one of the things that we all think about when we're starting to program in C++. Well, when is this a good situation to use a pointer? Well, if we have a sample that's in memory, and we take that data, we load it into memory, and then we have a pointer that's pointing to that sample. And then let's say that we want to load another sample. Well, what we could do is we don't need the first sample to be in memory anymore. So what we could do is we could just free that up and then load up the data for the second sample. Okay, and that's what a pointer allows us to do. It allows us to say, okay, I'm not using the cowbell sample anymore. I'm using this other sample. And so what I could do is I could free that memory up if I wanted to and load up the second sample. So that's why we're using a pointer here. Okay, so let's go back here and let's see what audio format reader source needs in order to fire up. So it needs a source reader. Okay, and this took me a little while to get to figure out how to get the source reader, but we could actually get it from audio format manager. So if we scroll down here, we can see here that we have this function called create reader for, and that we can load our file in there, and that returns an audio format reader pointer. Okay, so we could do format manager dot create reader for, and then we could just say my samples zero. Okay, so is that right? Or do we want the file? 1 second, just making sure that because this doesn't, I'm just making sure that I've got this right. So find child samples gives us an array of files. Yeah, so that's fine. So it gives us, so my samples gives us an array of files, and what we're doing is we're taking the file and we're creating a reader for that. Okay, make sure you don't do my file here, because this is just saying, hey, go to my desktop. Okay, so that's not actually the one that's actually loading the file itself. Okay, that's why we need this my samples here. So now we can say auto, this is, and we'll call this, so I need to go back here to format, audio format manager, and then I'll just call this format reader. Format reader equals create reader 4. And now what I could do is we can now that we've created a reader for it, now we can load that as our audio format reader source. So this is a pointer. Remember, this isn't just an audio format reader source. So what we could do is we could do p metronome sample. And there are a few ways we could do this here, but I could just use the reset method. And then I could do new audio format. I'm not sure if my syntax is right here. So we could do new audio format manager, or no, new audio format. I get all these classes mixed up. Audio format reader source. So that's the type of file it is. Then we need some initial arguments here. And then we can put our source reader here in here, and we can delete the reader when this is deleted. So we could say format reader, and then we can delete it once we can delete the reader once we're through with it. I think that I have the syntax right on that. Okay, so I'm just going to build this really quick, just make sure that it actually is the right syntax. Okay, cool. So that's fine. So now we've loaded it into our memory. So now it's loaded in memory, and I think that's have I just looking just to make sure that I haven't actually forgotten anything here. So okay, so that's fine. I think that's fine. Now, if we go into our actual, I feel like I'm forgetting something here. One second, just thinking. No, we're good. So now what we need to do is we can look at our audio format reader source documentation. And then here we have all of our stuff that we need to do to actually play the samples. We got get next audio block, prepare to play, is looping, all of this. Okay, so what we could do is we could use our we need our prepare to play method, because our file needs to know what sample rate that we're actually playing at. So we could do prepare to play. So one thing that we want to do is we want to make sure that this process is completed before we call prepare to play. So we could do if p metronome sample is not equal to null pointer, then we could call prepare to play. P metronome sample. Then we need the arrow operator here to make sure, because it's a pointer. So we got prepare to play, and okay, so we don't have our samples per block expected coming into prepare to play, so we just need to change that. So we could go back up here to our main component into prepare to play where it's actually called, and we could just do this. I could do, I'll do this, samples per block expected. So this is just when I call the metronome prepare to play in the main component. And right now it's giving us an error because we need to change how we're calling that in our actual metronome class. So here is our prepare to play, and this is an int, samples per block. And then here, I need to change it here in my actual function itself. And then here I can just call samples per block. And here I could call sample rate. And that should be fine. Okay. And so that's all good. I'm just going to build this really quick, make sure it actually builds. Okay, so that loads fine. I'm also going to do this real quick, just console out, just to make sure that this actually loads. File loaded. I'm just going to, so we're just going to make sure that this metronome sample isn't actually still equal to a null pointer. And we can see if we look down here that it says file loaded. So it loaded the file, okay. Okay, so just a few more things to do before we wrap up this tutorial. So if we go back to format reader source, we can see that we have a get next audio block that takes an audio source channel info reference. So what I'll do is I'll just, for now, I'm going to put this, so this would go in count samples. I'm just going to put this down here, and this, or I'll just do P metronome sample, get next audio block, and then that needs our audio source channel info reference. And I'm just going to comment this out for a moment, because that's going to give us an error right now, because we aren't actually bringing in the audio source channel info object reference into our count samples. So what I'm going to do, just to make this a little bit more descriptive, I'm going to change count samples to get next audio block. And then what I'm going to do is I'm going to actually change this to our audio source channel info object. Audio source channel info. That's a reference. And then what we could do is, so we can see that we're getting an error on buffer size, so we're just going to reshuffle some of this. So so we could do auto buffer size equals audio source channel info dot buffer. Oh, I'm getting mixed up. How did I call this in my main component here? So, oh, I didn't actually give it a name. God, sometimes I forget what I'm actually doing. I don't know if y'all actually get that at times. So buffer to fill dot buffer. So how did I call this in main component? So buffer to fill dot num samples. That's it. My brain's not moving as quickly as I'd like it to. So that should fix our errors here. And then what we need to do is we need to actually just change our description here in the metronome. So we go to count samples. That's not called count samples anymore. So that's called get next audio block. Sorry if you can hear my dog snoring. She's so funny. And then what we could do is we could just change this here. And what we need to do is put buffer to fill here. And then this should build fine now. Okay, so that builds fine now. And now I can get rid of this because I'm not using it anymore. Okay, so that's all I'm going to do for this tutorial. I think that's a good place for us to wrap up. Just going to take this and paste it here so we're not getting this little gray weirdness. And so in the next tutorial, what we're going to do is, so we have a situation here, and a few people have brought it up in the last tutorial, which is that, okay, so we were calculating when the click was supposed to happen, but we have the sample, so we have the samples coming in every buffer size, in buffer size chunks. So how are we going to actually get the sample to actually play when it's supposed to play, when it's supposed to actually click? Because that's going to happen sometime, more than likely that's going to happen sometime in the middle of the buffer itself. So we need to calculate when we actually want the actual sample to start playing, if it's in the middle of the buffer. So we're going to have situations where it's going to start playing in the middle of the buffer, and then what it needs to do is it needs to actually finish playing our cowbell sound in the next buffer of audio that comes in. And that's what we're going to do next tutorial. So I hope you enjoyed this. A little bit tricky sometimes, but we got there, and I will see you next time.